This is a setup for Microwave Training Lab MWL10. It consists of a gun oscillator. It uses a 10 milliwatt of gun diode encased in an aluminium body. It is provided with a calibration chart at 7 volts. Right now the micrometer is showing 6 mm. And as per chart, 6 mm refers to a voltage of around at 7 volt frequency of around 10.1 gigahertz. So it is generating around 10.1 gigahertz. Then a pin modulator. A pin modulator modulates the CW waveform at 10.1 gigahertz coming from gun oscillator. It uses the SMD pin diode. To prevent the reflections coming back to the gun oscillator, we have used an isolator. Isolator consists of a broadband termination and a ferrite isolator which is broadband in X band. Then there is a 20 dB attenuator. A calibration chart of 20 dB variable attenuator is also pasted on the variable attenuator. Then there is a fixed attenuator because it is using a 10 milliwatt of diode. So we have to connect a fixed attenuator so that the power is reduced in order to come in the range of VSWR meter and detector. Then there is a frequency meter. Again, the frequency meter has a calibration chart pasted on it. Then there is a slotted line which has a vernier connected to it for measurement of maxima, minima and standing waves formed in the waveguide. Then there is a directional coupler. Now the coupler has been connected in reverse direction because we are going to measure the directivity of this coupler. This is port 1, this is port 2, this is port 3 or coupled port, and the fourth port is terminated, and right now we have connected a short at port number 1 here. So we will be doing the directivity measurement by reversing the coupler using a shorting plate. Now we come to the setup of gun power supply cum VSWR meter. Now we select, there are different menus. We will select the gun bias first. In gun bias, the instrument is displaying a voltage of 4.86 volt and a current of 2.3 milliampere. Now, as per calibration chart, we will give a gun bias of around 7 volt. This is a slow rising power supply, so it is deliberately made slow in order to prevent the gun diode. So you can simultaneously see the current variation also. Now we have given a gun bias of around 7.02 volts and it is consuming a current of 201 milliamperes. Now we will select the pin modulator. Now in pin modulator the default frequency is 1 kilohertz, amplitude is 5 volt and DC offset is 2.5 volts. Now we'll press start and it will give a 1 kilohertz 5 volt peak to peak with a DC offset of 2.5 volt square wave to the pin modulator. Then we will select modulation signal. The default is internal 1 kilohertz. You can select mic for audio communication or USB for data communication later. Then finally VSWR. Now in VSWR you will see that it is right now showing a level of 3.7 millivolts. If the plunger of micrometer of variable attenuator is changed, you will see that it is showing over display. Now right now we have selected the range so that it is displaying at around 5.5 millivolts. Now in analysis we have time domain and FFT. If I select FFT, you will see that it is displaying a 1 kilohertz waveform FFT. Similarly, we can select the time domain mode and you will see that it is displaying the time domain waveform of detected waveform, and the level it is showing 5.4 millivolts. Similarly, in order to do the measurement, we will press measure. Now right now it is reading a maximum voltage of 5.4 millivolt. Now for this setup, we have connected a short at port number 1, and by replacing it with termination, we will measure the difference between two readings and we try to measure the directivity of the coupler. So for that we will select Vmax first. Now it has made this 5.4 millivolt as 0 dB, and now we will disconnect the shorting plate with the termination. We have disconnected the shorting plate. Make sure while doing the actual measurements, all the bolts and nuts have to be tightened properly, otherwise there will be an impedance mismatch and the readings will be erroneous. Now with the termination connected, instead of shorting plate, we will measure Vmin. So right now it is giving a directivity of around 15 dB, but it is much more than 15 dB. The reason being, the measurement of power is done with the help of detector, which is linear, which has to work in the square wave region, because the gun VSWR meter again is a square law device. So this reading will change when we operate the power of gun oscillator in such a way that it comes in the square law of the detector diode.